This is a video to show you how to solve 3 equations and 3 unknowns on your graphing calculator. The extension to more unknowns and equations is pretty clear, so if you can just follow this, you'll have it down. So first you take your equations and move all the variable stuff on the left and the numerical quantities on the right and line them up in columns with all the x unknowns together in a column and y's and z's. It starts to look like a matrix, and of course we're going to use matrix methods to solve this. There's a number of different ways you can do it on a graphing calculator. I'm going to show you what I think is the easiest. So I'm going to start with this example here. We'll go to second matrix on the calculator. We want to arrow over to edit, and we want to edit matrix A. So for 3 equations and 3 unknowns, we want to put in a 3 by 4 matrix. So 3 by 4 matrix. So that's 3 rows and 4 columns. So now we look at the first row. The first row is going to be 2, 3, 4, 119. So 2, 3, 4, 119. Then we look at the second row. It's going to be 5, negative 6, 7, 80. 5, negative 6, 7, 80. Then we want to look at the third row. It's going to be 8, 9, 10, 353. 8, so we got the matrix A in there. So we go to the home screen, quit and go home. Then we look at second matrix. And if we wanted to just print the name of the matrix on the screen, we would choose this. So choosing that, for instance, just prints the matrix A. The brackets mean a matrix. So here's our matrix that we entered. Looks okay. Then we want to go back to matrix and go over to math. These are the operations you can do with a matrix. So we want to go down to RREF, row reduced echelon form. A lot of words that probably don't mean too much to you now. That's okay. Then we want to print the name A, so we go to matrix and just print the name A. So we want to find the row reduced echelon form of matrix A. And here it is. You notice you have ones along the diagonals and numbers over here in this last column. Well, this means that x is equal to 12, y is equal to 13, and z is equal to 14. So that takes care of that. Let's look at another example. Let's try this one. The first row is going to be 2, 6, 0, negative 1. When the variable doesn't occur, of course, you have to put a 0 in its placeholder. So I'm going to go back to matrix A to edit it. I still want it to be a 3 by 4, so I just hit enter. Then I go back and find the first row again. 2, 6, negative 1. 2, 6, 0, negative 1. 2, then I look at the second row. It's going to be 0, 3, 3, 7. Then I look at the third row. It's going to be 4, 0, 5, 21. Okay, I got the matrix A in there. Go back to the home screen. Second enter will recall the command that I used last time. So I'll use that as a shortcut. So this is saying that x is 1.5, y is negative 0.666, and z is equal to 3. I want to point out here that convert decimal to fraction, which is the key math 1. Answer to convert to a fraction works with matrices also. So you get that x is equal to 3 halves, y is equal to negative 2/3, and z is equal to 3. Okay, let's do one more example. Let's go to matrix, edit matrix A again. We still want it to be a 3 by 4. So we want 1, negative 2, 1, 4. 1, negative 2, 1, 4. Second row, 1, 1, 1, 2. Third row, 3, 3, 3, 14. Okay, we got go back second quit. Let's go back to the home screen. Recall, well, that recalls the last thing we did, converting it to a fraction. So we recall again to the command before that, which is row reduced echelon form again. Here we get, oh, look at this. We don't have numbers along this principal diagonal here. Ones along that principal diagonal. That's bad news. What that means is that this either has no solution or an infinite number of solutions. If this bottom row comes out to be all zeros with a number at the end, then there's no solution. It's an inconsistent set of equations. If it comes out to be all zeros at the bottom row, then that means that it is got an infinite number of solutions. And that's it.